Welcome, athletes. Here's a little bit more about solving power equations where we have a fractional exponent on the variable. This is just a plain one. There's no context to it, so we don't know a whole lot about what might be going on behind the scenes. If you were to just charge in here and try to solve this, my recommendation is that you ignore this exponent of 7/9 and you just try to solve this like a regular algebra equation, like 21w minus 29 equals 131. Solve it just like you would solve that and then deal with the complications later. So my equation reads 21x to the 7/9 minus 29 equals 131. To start solving this, we'll add 29 to both sides. 21x to the 7/9 equals 160. Divide both sides by 21 to get the x quantity by itself. That will give you x to the 7/9 equals 160 21ths. 21sts. I guess I don't know how to say that right now. To handle the exponent, to get rid of it so that we have just plain x, the reciprocal exponent is one strategy for eliminating that. The reciprocal of 7/9 is 9/7. We'll apply the 9/7 power to both sides of the equation. And the effect of that is that when you multiply your two exponents together on the left-hand side, on the x, you'll get x to the 1. And that's just plain x, just like you want it to be. On the right-hand side, you have something that you need to compute on the calculator. 160 divided by 21 would need to be done in parentheses, and then raise that to the 9/7 power. If I put a calculator in here, let's see if you can see that. Parentheses, 160 divided by 21 raised to the 9/7 power gives us about 13.61. So that would be an estimate of our answer in this case. And you might have some lingering memory of a previous tutorial where they mentioned something about sometimes you get two answers, not just one. And in this problem, both portions of the fractional exponent were odd. And when that happens, we're only going to get one answer. You can check your work, so you don't have to just believe me on this. We can take the answer that we got for x and we can run it back through the original equation and see if that works for us. So let's do that. Move it over here a little bit more. My answer is sitting here on my calculator. I'm going to do 21 times the previous answer, and I'm going to raise that to 7/9 because that's what the original equation said, and then move my cursor back down so I can do regular subtract 29. 21 times my previous answer to the 7/9 minus 29, it should give me 131. And it does, it gives me exactly 131. Let's go try it with the negative version of your answer. Let's see if that is even possible that it would work. You know, what if you don't believe me that we don't get two answers here? So let me find, there's the answer on the calculator that we got where we assumed everything was positive. Now let's do, let's do this. We'll do 21 times, this time I'll use parentheses. I'll use negative of that answer. I'll raise that to the 7/9. Come down to subtraction and subtract 29. So what I'm saying here is I'd like to do 21 times, maybe the negative answer works. Maybe Nicole is lying to me. I'm going to raise that to 7/9 and then subtract 29. When I tell it enter, I get negative 189. That is not the same thing as 131. And so hopefully you're believing me a little bit more that we did not need the negative answer here as well. You can also come back here and remember about the odds. This is a 7th power. This is a 9th root. This is a 9th power and a 7th root. And neither of these roots will give you two answers. The odd roots they're not going to give us any multiple answers, just one answer for those. So I think this one is set. Let's switch it up a little bit to something where we do get to talk about multiple answers. Here's another one. In this one, to solve 14 equals 13x to the 4/3 minus 12. We want to try to isolate the x to the 4/3 first. Let's add 12 to both sides of the equation. We'll get 26 equals 13x to the 4/3. Divide both sides of your equation by 13. 26 divided by 13 is really friendly. It's 2. 2 equals x to the 4/3. And now we need to isolate the x. We need to handle this exponent of 4/3. And if we just sort of blindly cruise along and don't think about what's happening here, we would come along and we'll say, okay, the reciprocal of the 4/3 power is the 3/4 power. Let's apply the 3/4 power to both sides of the equation. That means that on the right-hand side, the 4/3 power and the 3/4 power get multiplied together. They give us one whole, so we have x to the 1, or just plain x, on the right-hand side of the equation. And then on the other side, we have 2 to the 3/4. And that gives us a value of approximately 1.68. Let me make these approximately symbols instead. That's rounded to the nearest hundredth. I get that from the calculator. If we go back and we check this one, coming all the way back to the top, here's my 2 to the 3/4 on here. I'm going to use the right-hand side of the equation. I'll do 13, the right-hand side of the original equation. 13 times my previous answer, raise that to the 4/3, come down for subtraction, minus 12, and I'm hoping that my answer comes up exactly at 14. And it does. So the approximation of 1.68 for an x value is working. That's good news. But then what about that two answer situation? Is this one of those? I have, in the original equation, I have an even numerator and an odd denominator. Well, that's nice. I think we need to analyze this a little bit more. When we're down here isolating the x in the very last step, this 3/4 reciprocal power really means that we're cubing a quantity and we're taking a 4th root. We're taking an even root, and it's that portion that causes us to get more than one answer. Because that denominator is even, it means an even root, like a square root or a 4th root or a 6th root. Those are the ones that give us more than one answer. So if I come here to my answer that I've already written down, 1.68, and I put plus or minus on there, now I think I've captured all of the answers that are possible. Let's go check this negative 1.68 though, just in case you don't believe me. So let me get 1.68 back on here. There we go. There's the 1.68 on the calculator. And now when I check it, 13 times, I want to use negative of my previous answer on the calculator. And I want to raise that to the 4/3. And then I need to come down for subtraction in order to subtract 12. And I am hoping that this also comes up to be exactly 14. Ta-da! It does. So in problems like these, when you don't have any context to help guide you, you need to keep an eye out for whenever you have a denominator that you've applied that is even. So we started out with an odd denominator, but that isn't the one that controls the situation. It's the one that you apply when you isolate the x that controls things.